Okay, so class content for today, which is Wednesday, the 1st of April. The chapter is chapter 40, Energy, Our Use and Our Need. So, chapter 40. So learning intentions for this chapter then. Describe different examples of renewable and non-renewable sources of energy. Like, a lot of this is going to be stuff you know already. It's so topical that, I mean, if you haven't discussed it in like geography or CSP, or as in, you'll know a lot of this. Consider our future needs in terms of energy, and research different energy sources and formulate and communicate an informed view of the ways that current and future needs on Earth can be met. Okay, so obviously that third one, we'll discuss some of the plans going forward. I mean, you probably know a lot of them already. Nobody has the answer to number 3. Like, how do we meet our future needs? Nobody knows that. So today we're just going to concentrate on renewable and non-renewable sources of energy. Okay, so how do we use our energy and where does it come from? So I suppose anything that you do at home, whether it's turning on a light switch or boiling the kettle, turning on your heating, having a shower, that energy has to come from somewhere. So there is some fuel somewhere that is being used to then convert it into what you use every day. And like, if you think about what you use every day, like, I'm literally sitting in the office in my room now, the lights are on, the fire's on, like, we do consume a lot of energy every day. And then think of the amount of people that are obviously consuming that, so it has to come from somewhere. In order to supply homes with energy, some source of fuel or resource must be changed into electrical energy so that we can use it. There are 2 forms of resources, okay? So again, you will have heard of this: non-renewable and renewable. Okay? Now, this is a definition. This is on the Leaving Cert Physics course as well, and this is a definition that was put to me, like, kind of, what is a non-renewable resource? And it can be kind of a tough one to define. I think I put on the spot, I was like, oh, but non-renewable resources, essentially, they are resources that when you use them, they will run out. They can't be easily replaced. So a non-renewable resource are limited resources. They will run out, and that will be unable to replace. Okay, so some idea that they're used up. Actually, I think the question that was put to me is what's sustainability? That's the question that was put to me. So what's sustainability? We talk about like sustainable living. What is sustainability? And I suppose it's the opposite of this. It's something that when you use it, it isn't used up. There's more of it. It doesn't run out. I suppose I think that's the question that caught me out. What's sustainability? Anyway, so non-renewable resources are limited resources that will run out and that we will be unable to replace. So in common terms, they're called fossil fuels. I think this is a little bit of a problem. I know when I'm listening to the news, like, you'll have some expert on it, they'll refer to them as non-renewable resources, or they'll refer to them as like peat and coal, or something like that, and then others refer to them as fossil fuels. They're all the same thing. Okay, so fossil fuels is sort of a more colloquial or layman's terms for it. As a scientist, it's non-renewable resources. That's like the overarching description. So fossil fuels are the remains of animals and plants from millions of years ago. So animals and plants that die, they sort of become compacted in the ground. Compressed, they have here. So kind of squashed in the earth over long periods of time. So long periods of time, thousands and thousands and thousands of years. Like the same way that people dig up bones of people from, very, very early times. Literally, the earth, kind of another layer of earth, another layer of earth, another layer of earth, and they become squashed under this earth. The fossil fuels are coal, gas, oil, and peat, and then to get them out of the earth, generally speaking, they're mined. Okay, so they dig into the earth. So fossil fuels have held energy in the earth for millions of years. So yeah, like the oldest ones will be millions of years, but even just to, I'm using inverted commas, the new ones, I mean, you'd need a couple of thousand years of compacted earth to generate that energy in the ground. And I suppose this is why they're not renewable, because you'd have to stop mining for them for another million years in order for them to be there again. You have to let plants and animals die and become compacted in the earth over many, many, many tens of thousands of years in order to have it. So, I mean, I suppose it's not that we could never have fossil fuels on the earth again, but we'd have to completely stop using them for another million years in order to be able to access them again. Um, so yeah, uh, they've taken a very, 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 very long time to become compacted and compressed in the earth and be turned into fossil fuels. They can then be mined. And I suppose the problem is that our energy needs are so great that they're being mined. There's too big a pressure being put on them. They're being mined and they can't be replenished that easily. As we said, it takes a considerable amount of time. So, I suppose mining them at the rate that people are. I mean, even people who, I know my own husband, his family have a couple of bogs down in Mayo, and like even they're, they've been using those bogs since, and they're privately owned. They're not, the only, they would go in every year and cut a section of the bog away, and they use the turf then to burn in their fires over the winter. And nobody has used them except that family. But I mean, that family as far back as, they had the tools to do it. And even they're starting to run out, and that's just private use. Like, so I know my husband's father's bog is like, they only have a maybe 10 more years and it won't work anymore. And I mean, even that, there's an argument that like years ago when they used to remove the turf, it was all done by hand, whereas now, my father-in-law has a machine that comes in, so he can cut a lot more turf than his father would have or his grandfather would have out of that bog. And I suppose in years gone by, you wouldn't have the fire going all day. If it got a bit cold, you put on a couple of jumpers. Whereas, now nobody wants that. Everybody wants to be warm and toasty. So, even on a private use, the energy requirements have increased. Anyway, so they need a solution. So the solution is to look at renewable resources, because renewable resource can be replaced and they won't run out. I mean, at least in the short, we've no reason to assume that wind will stop blowing or we'll lose the water in our oceans or, so I suppose we can't say they'll never run out, but, there's no reason to assume that they're going to start running out now. So examples, you need to know these examples. Most of these you're going to know. So wind power. Wind power has, I think, become one of the biggest renewable energy sources used in Ireland. There's plenty of wind farms gone up. If you drive across the country, you'll see them. There's quite a few of them now. Like if you're driving out, especially on the motorways where you've got kind of good view on both sides, like if you're driving cross country, you'll see a lot of these wind farms. They're a little bit controversial in terms of if you try to put them. I mean, obviously, to use them, they need to be within a reasonable distance of towns and houses and stuff. And apparently, they're quite loud. And they're not the prettiest things to look at, I suppose, in your back garden. So there's a lot of proposed wind farms that have been squashed, I suppose, by locals saying they don't want a wind farm near their house, which is a shame because they have to do something. But essentially, it is just a big windmill, and it takes so the wind catches in the blades of the windmill and it moves them. So moving energy, we discussed that before, is called kinetic energy, and then that kinetic energy is converted into electrical energy, and it can be used in our homes to turn your lights on. Water. So I think worldwide, energy generated from water is the next biggest after fossil fuels, I think. So this is using the energy within moving or falling water and changing it to electrical energy. So we have hydroelectric stations and biomass. So this is burning fuel like fossil fuels, except the fuel that they're burning. So we discussed that fossil fuels was dead animals and plants that have been compressed, whereas biomass is when you burn fuel from living things, so like burning wood from trees. So generally, if this is now, I suppose even if you're not burning the wood, even if you have like there's companies in like Norway, Sweden, who provide the, whatever the trees are called that grow there. They're very strong, and they can be used to build houses. So a lot of the houses in like Norway, Sweden, Denmark, Germany, they'd be built out of wood, and this is incredibly strong wood. So what they do is it's like massive conservation. So they use the wood, but for every tree they cut down, they plant like 5 trees or something, and this is how they make it sustainable, which is quite cool. And it's similar with this. So it is only a renewable and a sustainable source of energy if, when they cut the trees down, they replace them. So at the very least, 1 for 1, but for the most part, that's not what they do. It's like a 3 for 1 or 5 for 1 kind of scenario. And it's a bit like, I don't know, when you were younger, your mother cutting your hair and saying, "Oh, if you keep a cut, it'll grow really strong." It's like that. So some of these forests, if you look them up, some of these forests in like Norway are absolutely thriving, even though they're being used for, like hundreds of the trees have been cut down every day. But the forest itself is actually thriving because they're doing it in a sustainable way. So it is doable. Geothermal. So this is using the heat in the ground. So if you go kind of like not massively deep, but a couple of meters below the Earth's surface, there's a constant temperature there. So obviously on the surface, because of changes in weather, the surface temperature will change. And in Ireland, it's cold a lot of the time. But if you go just a couple of meters down, there's a constant kind of warm. It has a constant temperature and it's quite warm. I think it's like mid-20s or something. So what they do is they allow water to go down there, and then it's heated down there, and that heat that it picks up when it goes down there is then stored and used as electricity. Solar panels you've probably heard of. So they heat water that runs through them, and again, it can be used. That heat can then be used to generate the electricity in your house, or it can just be used to heat your water. Like there's kind of different, there's solar panels and there's photovoltaics, which will actually use the heat energy to provide electricity for your house. It uses the light from the sun. So it doesn't necessarily have to be roast and hot, I suppose, for solar panels to work. It just needs to be light. So, obviously every day it gets bright. Granted, in the winter, our bright hours are decreased, but you don't need heat. It's to do with light from the sun. Oh, sorry, they're talking here about the so solar cells. These are found in devices that transform light energy into electricity. So that would be what a photovoltaic plate does. You'll see it. Sorry, it's like this thing is one step ahead of me. Some calculators are solar powered, and you can get watches that are solar powered and stuff like that. So that's where they transform the light energy from the sun into electrical energy, and you can do that in your house as well. All right, so there's a good bit of information there, and it'll take you a while to kind of write down the notes. So I'm not going to go any further. But I suppose the main thing is that there are 2 sources of energy. What are non-renewable resources? Can you define them? List your fossil fuels. Have a brief idea of how they're formed. So I suppose if you know how they're formed, you know why we can't renew them very easily. So now you've got a good idea of what. Now we look at numbers next week. In terms of how quickly we're using these, we look at the numbers. But so why we need a solution, the solution being renewable resources, and you need to know like just a brief idea of how these renewable resources work. Okay, and then I have a nice short little homework piece here for you to do for next Tuesday.